Welcome everybody. We are going to talk about inverse trig here. I'm going to first talk about inverse sine. That's the first thing that we will go. So I'm going to go ahead and sketch it real quick. If I sketch inverse sine, I do end here at 2 pi. We'll have the middle part be pi over 2.
Take 2, by the way.
And 3 pi over. Now, this is, if you're watching this is probably like take 15 actually. Who knows? So it looks something like this. Yeah? Yeah? Is this correct?
Yeah.
All right, good. I'm not doing another take now. Okay, so now we want to try to find the inverse of the graph of sine of x. So this is y equals sine of x. Did I graph all of sine of x? The answer is no, viewer. I did not. I just graphed just one period of it. Now, inverses. Who remembers what an inverse is? It's reverse mapping of the input and the output. It's reverse mapping, also known as switching your x and your y. So back in Algebra 2, you probably learned if functions can have inverses by using the horizontal line test. Okay, that means that if we do reverse map the inputs and the outputs, that would not create a function if the horizontal line test is failed. So if we were to draw a horizontal line here, would sine of x pass the horizontal line test? Oh God, no, it does not. It hits right there and right there. All right, good job, everybody. Good job. It's fantastic. No, so when we take the inverse of sine, we can't take the inverse of what I have in red right here. But rather, since sine of x is periodic, I can actually do what I have in green here. What if I were to take sine from here to here? Is green right there? Will that pass the horizontal line test?
Yes.
Sure will. And what's this minimum value right here to the left of the origin? Negative pi over 2. So I can only use green for the inverses. Now, if I'm talking about quadrants, if we're looking at our unit circle, what quadrant would we be going from if we went from 0 to pi over 2? We're in quadrant
1.
And then from pi over 2 to pi would be quadrant 2, quadrant 3, and quadrant 4. What would this green part be right here? Between 0 and negative pi over 2. That would be quadrant 4 as well. Just we're going backwards. So just to remind you for unit circle. I have this in purple. So unit circle, so from here to here is pi over 2 to pi to 3 pi over 2, and 3 pi over 2 to 2 pi. That's going in that direction. If I were to go backwards, this would be this part right over here. Okay? So now we can define sine of x as an inverse function. So the inverse function here is when we, I'll sketch it for you. So inverse function, if you remember, it's when we change their range in the domain. So the range of green here is going to be the highest green point is, very good class, 1. And the lowest of green is, so that's the range. So now the domain goes from 1 to negative 1, negative 1 to 1. So we're going to go from here to here, right? This is 1, this is negative 1, and that's 1. Okay, and the domain of green goes from negative pi over 2 to pi over 2. So what this is going to look like is this right here. Okay, so this is what y equals arc sine looks like. Okay, now, if I were to ask you, when does sine of theta equal pi over 6? When does sine of theta equal pi over 6?
1/2.
Thank you. I thought I taught you this. 1/2. Wait, hold on. Crap, this could be take 3. No, we're good. We're keeping it in. I asked that wrong. That's hard to tell when that equals pi over 6. Wow, when does sine equal 1/2? Ah! Oh, now you know. Pi over 6, what else? There's more. 5 pi over 6. Technically, there's more. You can keep going by adding in periods as we go. So like another answer is not 7 pi over 6. That gives you negative 1/2. 11, no. 13 pi over 6. All right, we get the idea. All right, just add 2 pi to those. You keep getting more and more values. Because sine is periodic, you can get multiple answers. Now, what if I were to ask you, what is arc sine of 1/2? That's like me asking it as an inverse. Now, arc sine is limited. It can only go so far left, so far right, so far down, so far up. What is the arc sine of 1/2?
-1.
No. How about pi over 6? Okay. When does sine equal 1/2 at pi over 6? Now, why am I not including 5 pi over 6 as well?
Because it's restricted.
Because this is restricted. This arc sine right here has a restriction. The domain is from, and the range is negative pi over 2 to pi over 2. So our answers can only be inside of this. If I'm asking you any value between -1 and 1, our answers have to be between negative pi over 2 and pi over 2. Got it?
Sir.
Thank you for the sir. Let's talk about tangent. It's going to be the same thing. It'll go a little bit quicker, though, because... Not tangent. Cosine. We do cosine. Go a little bit quicker, though, because we start here, and we go here. Okay. Now, we can find this inverse very easily from quadrants 1 and 2. Okay? Quadrants 1 and 2 for inverse cosine. Because does that green pass that horizontal line test? Yes. If I go beyond it, would it pass it? No. If I did what I did with sine over here and I went left, would that pass it? No. So what quadrants am I in for? Yeah, so this is going to be in quadrants 1 and 2. And that's for, by the way, the inverse and arc cosine are the same thing. Same language. Okay, and then for sine, we're going to go into quadrants 1 and 4. Understanding it so far? Just lie.
Yes.
Fantastic. Okay, so if I were to sketch inverse cosine, what's this? Again, the range and domain are going to be a little bit slightly the same as arc sine, slightly different at the same time. So what is the domain? That's not going to change because it's going to be the range of cosine. What's the range of cosine? -1 to 1. So what's the domain of arc cosine? -1 to 1. Now what's the? I'll write that down. Domain is from -1 to 1. Now what is the range? Oh gosh, you're gonna ruin the video. I'm recording right now. You can't say names. Go away. Okay, so now this one is actually going to go from here to here. Okay, or up here would be our pi over 2. Okay, if you notice, green is decreasing. Why do you think green is decreasing? I've been saying this in class all the time. What ones decrease? The C's. The C's, they decrease. So this one's decreasing. So that's how what this one looks like. And then I'll label it for you too. So we have y equals arc cosine. Oh boy, I'm bad at writing. Okay, so now if I were to ask you over here, when does cosine of theta equal, I don't know, let's do 1/2 as well. When does that happen at? The pi over 3 families, right? Pi over 3, quadrant 1 and 4, so fourth quadrant would be 5 pi over 3, and so on and so forth. What about arc cosine of 1/2? That would just be pi over 3. Are we good so far? This is actually not the hard stuff yet. Like we're still good. Yes?
Wouldn't the maximum value for the arc cosine be
You know what? Thank you. That's a typo. It's pi.
5?
No. We fix it eventually. We're good. Thank you, unnamed sir. All right.
I'll drop my name in the comments.
You could drop your name in the comments. Okay. I'm gonna ask you a trickier question now. I'm gonna go put a tricky question here in, I don't know what color. Oh, blue. I haven't used blue yet.
Okay.
What is arc sine of -1/2? Okay, you said 7 pi over 6. I agree that sine is equal to -1/2 at 7 pi over 6, but that's not in my range here. It's defined.
It's defined.
It's defined.
Oh, great.
It's defined. Your answer has to be between -pi over 2 and pi over 2. So let's do this real quick. When does sine equal -1/2? Theta equals, I heard one of them, 7 pi over 6. What other one? Okay. Well, 11 pi over 6 is in quadrant 4, yeah? But the answer is not 11 pi over 6 because is that in my range?
No.
How else can I say 11 pi over 6 so that I'm in my range? Subtract it. Subtract the period. You're going to get? No, a period would be 2 pi, not pi. What do you get? I heard it back there. The yappers. Yeah, what? -pi over 6. The yappers in the back said something right.
That makes sense.
All right. Okay. Let's do arc cosine of -1/2. No, it's not -pi over 3 because the range here is from 0 to pi. No! It's what? No! It's got to be between 0 and pi. Okay, let's take this a step back. When does cosine of theta equal -1/2? Theta equals? I promise you, I taught them all of this. What was that? And what else? No, 5 pi is positive. 4 pi over 3, so on and so forth. Is one of these answers in my range? Yes, it is! I'll put the warning in the description.
Oh, this could be a reel. This could be a viral reel.
I teach these kids all this stuff. They were tested on it. They did pretty well on most of this stuff.
You missed till at least 30 guys.
Yeah, we just started.
Are we on take 7?
No, we have another function to do. Yes. No, this is terrible. No one's going to want to watch this. There's no information that's any good to anybody in this video. I'm glad you're enjoying it because I'm not. All right, to sketch tangent. Oh my gosh. We go over here to pi. We have a vertical asymptote here at pi over 2. And I taught you this. I did teach you everything. Everything you know. I don't know if I should take credit for that. Hey, you can fix my mistakes, no problem, but I don't have a mistake. Y'all have no clue what's going on. We went over a tangent like this, yeah?
Yes.
Okay. Does the horizontal line test pass this?
Yes.
Yes, so we can use what as our range here for arc tangent. We can use, it looks like from 0 to pi. I'm here to tell you no, we don't though. We don't. This is where it gets confusing. They had back in the early 1700s or 1800s, they had a consortium. What that is that's a bunch of math people all came into this one room, and it was like hundreds of them, okay? No, not you. You would have got kicked out very quickly. Euler was there. Bernoulli was there. John Herschel was there. These are the mathematicians that helped with inverse trig stuff. They even brought some people back from the dead, like Euclid, Archimedes. Let them die. No, it was an important consortium. And they all had a meeting about tangent. They were like, all right, we need to figure out inverse tangent. What quadrants do you want inverse of tangent to be in? And they were arguing. It was days and days long. They have eventually discovered, hey, I think it's easier if we do this for tangent. Why don't we just go ahead and use the green right here, because this function is continuous all the way through of the green. There's no breaks. There's no vertical asymptotes. So for this right here, I can go ahead and sketch this as now of the green. What is the domain? Or let's go with this. What's the range of my green here? It's from negative pi over. Yeah. So for arctan, this domain is going to go from negative infinity to infinity, because the range. There should be parentheses. The range. I have an eraser, I think. I do. The range of green is negative infinity to infinity, so the domain for arctan is going to be negative infinity to infinity. All right. What is the domain of green over here?
Negative pi over 2 to pi over 2.
Yeah, so we're going to go from, you can't touch negative pi over 2, right? Yeah. So from negative pi over 2 to pi over 2. What quadrants in the unit circle are we using for those? We're using 1 and 4. This is going to follow the same rules that sine does. All right. All right, if I were to sketch this thing, it looks like this. In these horizontal asymptotes, there's 2 of them here. Pi over 2 on the top, negative pi over 2 on the bottom. Okay? So now, if I asked you what arc tangent of, I have to give you an easy one, a softball. What's arc tangent of 1?
No, wait.
0. You said 0. I don't think teaching is for me. You're closer. If you can't hear, I've heard 0. I heard pi over 2. Someone said, nope, let's try negative pi over 2.
We'll get it eventually.
I don't know. What was that? You said 1?
No, it's pi.
It's pi over 4. That was the softball.
You didn't draw the graph like properly.
If you can't hear, I just got insulted. Maybe they're sick of me insulting them. We can do better here. Arctan of negative 1 is? I don't know if we just lucked out or we knew that one. That is actually negative pi over 4. All right. If you enjoyed this chaos with this video, holy cow. First off, pray for me. I don't know if I'll be making any more videos after this one.
Like and subscribe and ring the bell.
Like, subscribe, ring the bell, all that stuff.